Okay, here's part two. I wanted to show you something though. On the last problem, really quickly, I went to Wolfram Alpha, and this is worth knowing. You have to be very careful with Wolfram Alpha when you're doing trig. The first thing, this isn't a huge deal, but the first thing, I forgot my parentheses on I wanted to differentiate 4 cosine over 7 tangent x, and always look at how Wolfram Alpha translates that. They did it correctly. They translated it correctly. I just entered it correctly. It took this as 4 cosine x over 7 times tangent x. So I redid it and put the 7 tangent x in parentheses and got what I was supposed to be doing. I want you to look at the answer, though. The answer Wolfram Alpha gave me looks very different from the answer that we got. But that's all the trig identities involved. That's why when you do a trig problem on Wolfram Alpha, or even in the book, when you look at the back of the book, you may see very different forms, but they're the same. So here's even another form, here's another form, and none of them really look like the forms we got. So I didn't want to take the time to convert to this form right now. I did do that though, so if you want to see how to do that, just using trig identities, just let me know and we can go over that. So just end of story here. The answer that we got is definitely the same as this answer. And one way you can do that without going through the trig stuff is graph both answers, and they should look exactly the same on your graphing calculator. So anyhow, I just wanted to quickly do the next question because this is one that a lot of students make really, really complicated, and it isn't. So what a lot of students will do on something like this is go right to the quotient rule. The bottom times the root of the top minus top times the root of the bottom. And I always say never use the quotient rule if you have a constant on the top or the bottom. So I have a constant on the top. So what I'm going to do here is I'm going to use a trig identity. Tangent would be that. Or you can even change that tangent to sine over cosine and make this cosine over sine, but then you'd be forced to use the quotient rule. This is the best way to do it because the 1/10 is your constant multiple that you can ignore. And so this problem, it turns out if you know what the derivative of cotangent is, you're done, and you do. The derivative of cotangent is negative cosecant squared. And I'm just going to rewrite it quickly. How about this? Negative cosecant squared over 10. And that's y prime. So also look at my notation. I would mark this wrong because this is equals, this is equals, this is equals, this is not equals because these expressions are not equal, obviously, because this was the derivative. So learn from my mistake there. Make sure you pay attention to this notation because they would not accept that on an AP exam if I didn't have the derivative. So thanks for watching. Stay tuned for more exciting videos.